Hi everyone, it's Math with AUB. In connection of foundation semester, let me continue our journey of teaser series, frame number 13. As usual, I have selected a question from set theory, exponential equations, log chapter, and the third one, quadratic. Let's go to question number one without wasting time. It's a good one. We have given a diagram. We have given three sets A, B, and C. A, B, and C. They are all overlapping. Overlapping means A intersection B is something, A intersection C is something, B intersection C is something, A intersection B intersection C is also something. Overlapping means they must have at least one element in common. Furthermore, it is given to us if epsilon shows in these cases the universal set. Normally, universal set is written by you. Here in this book, it is denoted by E. First, it is given to us if comprises A, B, and C. Given that number of total elements in the universal set are 50, find the value of x. Find the value of x. Let's see question number one. Oh, it's not working. Yes. Now, total number of elements is 50. Just take care not to repeat. Take care not to repeat. Take all these things, add up to 50. Take all these elements that given to whether it is intersection only in A or only in B without repetition. Taking the elements of A first, they are 2x, x plus 1, plus 3, plus 2. We have done with A. 2x, x plus 1, 3, 2. Don't repeat. Different x minus 1, 0 and x plus 5 plus x minus 1, x plus 5 plus 0 is equal to 50. It is given to us all three elements of A and B. See, they have cardinality, they have the number of elements totally 50. Universal set has 50 elements. All lies in A, B, and C. A, B, and C. Either in A, either in B, either in C, either in A, B, either in B, C, either in A, C, or in all three A, B, and C. Okay, cool. Here, solve for x. 2x, x, 3x, 4x, it will become 5x. Here is positive 1, negative 1, cancelled out. 3 plus 2, 5, and 5, it's our 10 is equal to 50. Move 10 there. 5x is equal to 50 minus 10. So 5x is equal to 40. Our x is 40 divided by 5. X is equal to 8. X is equal to 8. X is equal to 8. So we have solved question up part number A. Value of x is 8. Value of x is 8. B, it's given to us what we have to find out. A good question. B, number of elements in B intersection C complement. B intersection C complement. C complement means excluding C, excluding C, excluding C, and we have to restore B, and we have to restore B but not C. 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 Let's see how. Let's see how. We have to restore B not C. Look at this. These are the elements. They are present in B. B, only B, only B, not C, only B, not C, only B, not C, only B, not C, only B, not C. That's this one. Only B but not C, because B intersection C complement, B intersection C complement, B intersection C, B intersection C complement, B intersection C complement. We have to restore B with C complement. With C complement means exclude C and taking the rest of B. Rest of B. They are, we have x minus x plus 1, x minus 1 is equal to, we have to find out this one, as 1 cancelled out. This is 2x. Value of x is 8. Value of x is, we have already found 8. 2 at the 16, 2 at the 16. So number of elements in A intersection B intersection C complement is 16. B intersection C complement is 16. Here we have also given that A complement intersection B complement, A complement intersection B complement. A intersection B complement, A complement intersection B, A complement intersection B. We have to restore B but not A. We have to restore B but not A. We have to restore B. That's RB. We have to take B. Now we have to omit this portion. We cannot take x plus 1 because we have to restore B but not A. We have to restore B but not A. We have to restore B but not A. They both belong to A. They both belong to A. That is the portion. That is x minus 1. That is x minus 1 in that case. X minus 1. So value of x is 8. 8 minus 1 is 7. 8 minus 1 is 7. 8 minus 1 is 7. Finally, we have to find number of elements in A intersection B intersection C complement. A intersection B intersection C complement. We have to restore the intersection of A and B but not C. We have to restore the intersection of A and B but not C. Look at this. That is the portion common to all. That is the portion common to all A, B and C. A, B and C. A, B and C. We have to restore A intersection B but not C. A intersection B but not C. We have to restore that portion. That's our portion. That's our required portion. That is our required portion. That is A intersection B, C complement. Intersection of A and B with C complement, with C complement, with C complement. That is the result for this. So we have only x plus 1, x plus 1. Number of elements in A intersection B intersection C complement. That is the portion. That is the portion. Intersection of A and B excluding C. Intersection of A and B excluding C. That is the portion. That is the portion. That is our x plus 1. Value of x is 8. Value of x is 8. 8 plus 1, 9 is our answer. 8 plus 1, 9 is our answer. 9 is our answer. That is there is another formula for 3 sets. It is a typical one. I am also going to write for you as well. Just apply common sense. In set theory, repetition is not allowed. Repetition is not allowed. Don't repeat. Take every element single time and you are going to get through. You are going to get through. If you want to apply formula, orthodox formula, let me write for you as well. Number of element in A union B union C. It shows total. It shows total is equal to number of elements in A, number of elements in B plus number of elements in C minus subtract, decrease the intersections of both AB, then A and C, then B and C. Eventually you have to restore the overall intersection of A intersection B intersection C. A intersection B. That is for 3 sets, whether they are overlapping or not overlapping. Something like typical. Let me explain to you. A union B union C shows total A individual B C, intersection of A B to be deleted, intersection of A C to be deleted, intersection of B and C to be deleted, and we have to restore the intersection of all 3 A B and C. That's the formula for. You can utilize same formula here to get value of x. Okay, cool. Moving to question number 2. Moving to question number 2. We have, I have changed this question a bit. In your book, it is written that Jake has proved quartic formula and he has committed a mistake. You are asked to find its mistake and be a victorious. I have changed this question. I am about to prove this quartic formula and what are the sum and product of the roots as well as the nature of the roots for you. Okay, cool. Let's see and find out. How to prove quartic formula? Take quartic general form of quartic equation. Quadratic equation, that is ax square plus bx plus c is equal to a. Look, here it is explicitly mentioned that a does not equal to 0. If a is equal to 0, then it is a linear equation. Then it is a linear equation having root minus c over b. Only answer. If a is equal to 0, if a is equal to 0, then it is no more quartic. It is a linear equation having this root. Okay. So it is, you must mention that a does not equal to 0. If a is equal to 0, it is no more quartic. Okay, cool. Divide by, we have ax square divided by bx divided by c over a 0 over a. Okay, cool. Cancelled out. X over a plus p over x plus c over a is equal to 0. Okay, that's our a square. Convert this one into perfect square x square. There must be twice, and x. We have b over a. We have formulated 2. So I can write b over 2. Look at this one. 2 cancelled out. 2 cancelled out. Same quantity. We have b over a times x. B over a times x. We have to restore the beauty. A square 2ab plus b square. Square of this one we have to manage from our own side. Add as well as subtract. A square 2ab plus b square. First term twice, first into second, second square of second. Add as well as subtract. Plus c over a same. Plus c over a same. A is equal to 0. Now shrink this. Make it sucking. Thus it is how to close this. Take first one without a square, third one without a square, the symbol of the middle one. First one without a square, third one without a square. Take the middle symbol only. X plus b over 2a whole square. Here we have add as well as subtract. Shift them on the right hand side. It will become b square over 4a square. They turn to be positive on the right hand side. Minus c over minus c over a. Okay. Let me write this step here. X plus b over 2a whole square. Taking LCM. Taking LCM. 4a square is the LCM. B square minus 4ac. B square minus 4ac. I am interested in x. I have to solve for x. In order to prove quadratic formula, I am interested in x. Taking square root both sides. X plus b over 2a whole square plus minus times b square minus 4ac over 4a square. Square and root cancel. X plus b over 2a is equal to plus minus. The numerator is not a perfect square quantity while denominator is. So it is retained in the square root. B square minus 4ac. Square of 4 is 2. Square root of 4 is 2. A square is a. It will become 2a. Shift this one on the left hand side. Solve for x. You have the beauty of quadratic formula. Plus minus b square minus 4ac over 2. Okay, cool. Denominators are identical, homogeneous. Write one time, no transition in the numerators. Minus b plus minus b square minus 4ac. That's our required. That's our required quadratic equation. That's our required quadratic equation. We are asked to also, what do you mean by sum and product of the roots? Sum them. These are the answers of x, roots of the quadratic equation. One is minus b plus b square minus 4ac over 2a, sum them, plus other must be negative, plus minus b square minus 4ac over 2a. Denominators are identical, it is sum. SVM. Okay, cool. 2a, no transition in the numerators. Root b square minus 4ac minus b square minus 4ac. Cancelled out. Minus b, I have minus 2b over 2a cancelled out. So sum of the roots is always minus b over a. Sum of roots is minus b over a. By b means coefficient, negative coefficient of x divided by the coefficient of x is square. Similarly, in the same token, one can prove the product of the roots. I am going to prove product of the roots for you as well. Let me drive this. Okay, cool. We have managed quadratic formula. Good one. Now product of the roots. Product of roots. Multiply them. Minus b plus b square minus 4ac in square root overall 2a times minus b square minus 4ac over 2a. Okay, cool. This is the ideal situation of difference of 2 square. There is positive, there is negative. The only difference between two brackets, between two parentheses, positive, negative. It is tantamount to a square minus b square. Instead of a, we have b square, negative b square minus root b square minus 4ac whole square over 2a times into 2a times 4a square. Okay, cool. It will be b square. It will be positive b square Let me multiply minus as well. Square and root cancel. Multiply minus. It will become minus b square plus 4ac over 4a square. 4a square cancelled out. We have 4ac over 4a square. Cancel out, cancel out. C over a. So sum of the roots is negative b over a, and the product of the roots is c over a. C over a. C over a. Okay, cool. Moving towards the final question of the frame 13. Find value of x when x raised 3 over 2 minus 8 times x raised negative 3 over 2 is equal to 7. Solve for x. Solve for x. Solve for x. Let me do this for you. Okay, cool. Shift 7 there. X raised 3 over 2 minus 8 times x raised minus 3 over 2 minus 7 is equal to 0. Tell this quantity to be positive, or you can take x is equal to 3 upon, let me write x raised 3 over 2 minus 8 over. In order to make power positive, shift into denominator. X raised 3 over 2 minus 7 is equal to 0. Minus 0. Or take LCM or multiply x raised 3 over 2. Overall, you are going to get through of the, you are going to get rid of the denominator. It will become x raised 3 over 2 whole square minus 8. This must be there. 7 times x raised 3 over 2 is equal to 0. Shift x raised 3 over 2 on the right hand side. It is about to vanish. Look at this. X raised 3 over 2 whole square minus 7 times x raised 3 over 2 minus 8 is equal to 0 times x raised 3 over 2. I am not cancelling this out in order to show you the beauty. It's our square term, power 1 term, and this one quadratic, ideal quadratic. X raised 3 over 2 overall square minus 7 times x raised 3 over 2 minus 8 is equal to 0. Okay, cool. There is 1 8 the 8, 8 minus 1 7. 1 8 the 8, 8 minus 1 7. Ideal situation for middle term breakup, or you can apply quarter. Middle term breakup is good one. X raised 3 over 2 whole square minus 8 times x raised 3 over 2. Positive 1 time x raised 3 over 2 minus 8 is equal to 0. Look at this one. Minus 8 plus 1, we are going to have again minus 7 times x raised 7 times x raised 3 over 2. Okay, cool. X raised 3 over 2 common. What remains from here? One more. X raised 3 over 2 minus 8. This is quadratic. It can be written 2 times. One common, one remains. Okay, cool. Nothing common, one common. X raised 3 over 2 minus 8 is equal to 0. What about this? Both brackets are identical. We are good to go. X raised 3 over 2 minus 8. Another bracket is x raised 3 over 2 plus 1 is equal to 0. Okay, either or. X raised 3 over 2 is equal to 8. X raised 3 over 2. 8 can be written as 2 cube. 2 cube. Squaring both sides are taking power 2 over 3 both sides. What is power? 3 over 2. In order to get rid of the power 3 over 2, take the power 2 over 3 both sides. X raised 3 over 2 raised 2 over 3 times 2 cube raised 2 over 3. Okay, 3 3 cancel, 3 3 cancel, 2 2 cancel. X is going to be 2 square. 2 square means 4. X is equal to 4. X is equal to 4. What about this one? Other bracket x raised 3 over 2 plus 1 is equal to 0. So x is equal to 3 over 2 is equal to minus 1. In order to get rid of 3 over 2, take power reciprocal of the power, reciprocal of 2 over 3. X raised 3 over 2 raised 2 over 3. It is equal to minus 1 raised 2 over 3. 3 3 cancel. This is x is equal to minus 2 raised 3. 2 raised 3. 2 raised 3. Minus 1 is the value of iota square. Minus 1 is the value of iota square. Iota square times 2 over 3. So it is going to be iota raised 4 over 3. Iota raised 4 over 3. And it is not the real root. It is not the real root. We are interested in real roots. So that's why our only answer is x is equal to 4. Our only answer is x is equal to 4. That is also true. But when it is given to you, you are solving for complex values as well. Imaginary complex values as well. We are restricted for real. So x is equal to 4 is the only answer in this one. That's my tiny effort on the number 13. In teaser series, Frame number 13 for you guys. It's all by itself. Next.